Welcome to Module 5, OpenNMS Alarms. This module will cover OpenNMS Alarms-related documentation, how alarm information is kept in the OpenNMS database, how to configure alarms, the alarms lifecycle, and handling alarms, with demonstrations scattered throughout the module. Note, throughout this module, all demonstrations have been rehearsed, and GUI or DB artifacts may remain. The OpenNMS Alarms documentation is found in the Operation Manual, Deep Dive, Alarms. Define an alarm as an aggregate of one or more events based upon some criteria defined within the event class. The criteria in the event element is alarm data, and the linking attribute is the reduction key. Event data is fixed. It relates to a specific occurrence. Alarm data is a bit flexible. The flexible elements include acknowledgement, clearing, escalation, and temporary and persistent notes called sticky notes and journal memos, respectively. Any event class with a log message element dest attribute value of do not persist will not be processed as an alarm. Alarms are action items. Not all event classes should trigger alarms. Just over 3,100 of the 17,000 plus OpenNMS installed events trigger alarms. The introductory demonstration will use the events Node Lost Service and Node Regained Service. There will be a quick review of events, notifications, destination paths, and resolution events. Each attribute of the demo event's alarm data element will be explained. SSH will be stopped on localhost. Observe the event. Observe the notification. Observe the emails. Look at the alarm in the GUI. Examine the alarm-related DB tables. Create a DB alarm SQL. Modify alarm info. Note the GUI and DB changes. This is the Node Lost Service class definition in OpenNMS events.xml. The event UEI, description, log message, and severity will be stored in the alarms table. The severity can be elevated in the alarm. The alarm data element will be covered shortly. This is the Node Regained Service class definition in OpenNMS events.xml. This is the event that resolves the node lost service if an event's resolution event occurs. The log message of the resolution event will replace the log message in the alarm GUI and DB table. This is the definition of the node lost service notification. Focus on the destination path email admin, which targets the admin group, whose members are admin and def user. This is the auto-acknowledged element for Node Regained Service. Returning to the Node Lost Service event class definition and focusing on the alarm data attribute from the documentation, the reduction key uniquely identifies a problem's signature and is used to reduce events so that only one problem is instantiated. Most commonly, the event's unique event identifier is used as the least significant portion of the reduction key, followed by other event properties, each separated from the other by a colon. DB name refers to the distributed polar name, which is the name of the monitoring location where the event occurred. Node ID is the ID of the node. Interface is the IP address associated with the event. Service, in this demonstration, this will be SSH. There are 3 alarm types. 1 is for problem, 2 is for resolving, and 3 is for a notification alarm. AutoClean instructs alarmd to retain only the most recent event that has been reduced into an alarm. For alarms that produce many events, this serves as a way to reduce the size of the most recent events in the database. The Node Regained Service event adds one attribute to the alarm data element. ClearKey is used in alarmd's pairwise correlation feature. When configuring a resolution alarm, you can set this attribute to match the corresponding problem alarm's reduction key attribute. There is a caveat in the documentation to avoid using AutoClean with alarms that have pairwise correlation, types 1 and 2, that match problems with resolution. It may delete all the problem events, erasing your ability to study an alarm's history. To create an alarm for a downed SSH service, follow these steps. First, make sure SSH is running with system control status SSHD. Shut it down with system control stop SSHD. Note the time is 2:13 p.m. Make sure it is shut down using system control status SSHD. Return to the GUI. Note that Daisy is logged in, and note the relevant event and notification. Note event 203. Click on Status Notifications, All Outstanding Notices. This is notice number 36. Note at the bottom that dev user and admin have been notified. View the emails of root, the admin email address, and dev user. Notification 36 is present in both users' emails. Return to the GUI and click on Status Alarms. Click on All Alarms Summary. Alarm 14 is the only alarm listed. Click on that. Note the reduction key. The log message and description are defined in the Node Lost Service event class. Scroll down to view the other event info, including the event ID. The sticky memo and journal fields follow. Return to the database to look for a suitable table using \d. The alarms table looks promising. Select asterisk from alarms. Based on the alarm ID of 14, this is the alarm to focus on. Get the definition of the alarms table using \d alarms. Some things to note. There is a service ID, but no foreign key tie to the service table. There is also a sticky memo field and a foreign key tie to the memos table. This looks promising. There is also a node ID field and a foreign key tie to the node table. Get the definitions of the memos, node, and service table. \d memos. Most of these fields will probably be used in the alarms SQL statement. \d node. This table has been used in previous modules. \d service, although not referenced with a foreign key, we can use this table to get the service name given a service ID. As a check, select asterisk from memos. There is nothing in the memos table at this time. Back in the GUI, as Daisy, add this sticky memo to the alarm. This is the first sticky memo added by Daisy. Save the sticky memo. The screen will recycle. Check the PSQL for the memo. Type select asterisk from alarms. Now there is a value for sticky memo. The value is 3. Type select asterisk from memos. And a memo is present. The memo ID is 3. The author is Daisy. Note the created and updated time are the same. There is not a value for the reduction key. Return to the GUI and add another sticky note as Daisy. This is the second sticky memo added by Daisy. Save the memo. Return to the PSQL and type select asterisk from alarms. The sticky memo value is still 3. Type select asterisk from memos, and the result is that another line has been added to the body field, and the created and updated fields no longer match. Perform one more test on the sticky memo by logging out as Daisy and logging back in as dev user. Click on the Alarms donut in the Status Overview. Click on View Alarms, and then click on Alarm ID 14. Scroll down to the Sticky Memo text box and enter "This is the first sticky memo added by def user." Double-check the sticky memo in the GUI. Return to the PSQL. Type select asterisk from alarms, and note that there is no change in the column values. Type select from memos, and note the following: the updated value has changed, the author value has changed from Daisy to def user, and the text that def user added to the sticky memo has been appended to the body field. Now test the journal memo text box by entering the following text: "This is the first journal memo added by def user." Click on Save. Scroll down to verify the journal memo was saved and return to PSQL. Type select from alarms. There should be no change in any of the values. Type select from memos. A new record has been created. It has an ID of 4. The created and updated fields match. The author is def user. The body matches the text that def user entered into the journal memo. And there is the addition of a reduction key value, which matches the related alarms reduction key value. The type is reduction key memo. The queries select alarm ID, sticky memo, reduction key from alarms, and select asterisk from memos reveal how the alarms table entry is tied to the memos table entries. The sticky memo, memo ID number 3, is tied to the alarms sticky memo and is therefore tied to the alarm with ID of 14. The journal entry, memos ID number 4, is tied to the reduction key. Other alarms over time with the same reduction key will use the memos record number 4 as a journal entry. The reduction key is fairly specific as it combines the UEI, the node ID, the interface, and the service. The alarms and memos tables having been well examined in this module, it's time to build an SQL statement that joins alarms-related tables together. That's coming up in Part B of Module 5.